So as the last presenter in this session, I can be a bit more philosophical and looking forward. So in this presentation, my co-authors Henny van Lanen and Tom Gleeson, and I would like to take you back to the basics of drought definitions. But before I do that, I want to see if you're still awake. So I'll do a little quiz. So looking at these pictures on these slides, so which one do you think represents or is a river? So I won't do a head count, but probably you'll say the second one. But I can tell you all of them. So the point that I want to make is that a river can have different forms. So for example, if a river is frozen, it's still a river. If it is dry for a time, it's still a river. Might be some, not everybody might agree, like in this case where the river was dry for 20 years in Spain. But also if there's a lot of if the river is canalized or diked or diverted or all these human influences on river systems, then we can still say, it's a river. So what I want to explore a bit here is that what is true for rivers might be true for drought as well. And that is in line with a recent paper of Benjamin Lloyd-Hughes, where he actually argued that there's no universal drought definition, at least not if you're quantifying droughts. Because if you look at it qualitatively, there's these general drought definitions that you're probably all very aware of. If you want to use these and look at it quantitatively, then all these questions pop up that you need to answer. And the only answer to these questions lies in impacts of drought. And if we look at the impacts, they are really related to different types of drought. Well, we've seen them in these in this session before, so hydrological drought and soil moisture drought, and eventually everything is related to climate variability, anomalies in precipitation or temperature. And this is what we normally call propagation. And this propagation of a drought through to the impacts in the end is of course related to the hydrological cycle. And this is what we like to study as hydrologists, processes related to the hydrological cycle. It's what we also put in our models. But if we go outside into the real world, and especially if we go outside of this building, we see this. And this is something that is more and more apparent, especially if we go to global scales. Well, there's almost no natural catchments left. So, and of course all these human influences on the hydrological cycle are important. For example, related to irrigation, abstraction of groundwater, building of reservoirs as well, eventually probably leading up to dry rivers. So much that we can also say, well, it's not a hydrological cycle anymore, but we can talk of the hydrosocial cycle. In this scheme they represent water flows to money. So you see a lot of water abstraction and use for irrigation, and these might really exacerbate drought events. But of course also the other side. So for example, reservoirs or water management can alleviate drought events. And if we look at it from a water balance perspective, you can see that these anthropogenic influences can be just put as an additional inflow and outflow of your water balance. So if we look to the scheme again, so where does the human influence kick in? So humans really influence, for example, soil moisture, discharge, and groundwater. And I think, like, as hydrologists, we are interested in finding out, understanding hydrological processes. So I think we should also include these anthropogenic processes to be able to understand the total system. For example, if we start with an average situation, no drought, then climate variability, as I said, can cause, in this case, for example, lower groundwater levels, but also human effects, for example, groundwater pumping can cause low groundwater levels. And then the question is, what actually happens if both occur simultaneously, and how do they interact and feedback? So, for example, during a drought event, will abstraction increase because more water is needed for irrigation, or maybe there will be some thresholds saying that, well, after a certain, if it's really dry, then no more water can be abstracted, and actually there's no more groundwater abstraction. But these interactions are still not really well studied. So this is a very important point if we are trying to include the human processes. So I'll spend some time on this slide. So what I said before, so if we look at the natural processes, drought is related to climate variability. And climate variability, that's what we see on like a monthly, a yearly timescale. But if we look to longer timescales, decades and centuries, then this climate variability can be on top of a long-term trend, and that's what we call climate change. And that can lead, for example, to aridity in some areas around the world. Same actually for human processes. So if we look at the really long timescales, then the human influence can, for example, lead to continuous groundwater depletion and these like rivers drying up in like decadal timescales. But on top of that long-term trend, there might be variation, and these short timescales is actually where it gets interesting, where this interplay with drought becomes important. If we really look at then specific areas around the world, and we're starting to look at time series, what we normally do if we want to study drought but not climate change, then we take off the trends. So we might need to do the same for the human influence as well. So we might need some detrending. So that is something to take into account. Going back to a more conceptual scheme. So this is what we know, what we are actually studying a lot. So especially this part, we've heard a lot today about the effects of climate variability and how that then influences the hydrological system and how droughts develop. And we really learn a lot from these studies. And recently there have been really nice, cool studies on what actually the impacts of a drought are to society. And I think we should add this arrow here, looking at the responses of society to a drought and how that influences the hydrological system. And we can see that also as like society is an additional driver of drought. Now I know that this is quite, it's quite controversial, and there is some discussion about the terminology here. So you might want to say, well, the human influence is not a drought, so you could call that a water scarcity. But we want to argue here that it's not, the name is not actually important. So you can say drought and water scarcity, you can say climate-induced drought and human-induced drought, but it's really about studying these these processes that I think are often neglected. So, well, we have to take into account that this is part of a more complex system. So if we include all the other processes, then, well, there's indirect effects of society on climate, feedbacks, but also we shouldn't forget the ecosystem and all the processes that are related to that. But for now, I think we should keep it a bit simple and start investigating these processes additional to the natural processes that we have been studying a lot up to now. And that still fits within the qualitative general definition of drought. Only, well, we have to be a bit flexible and include the human effects as well. And I think as hydrologists, to really understand the hydrological system, we should be curious to these kind of processes as well, looking at the right timescales, of course. And actually, as drought scientists, we are lacking behind a bit, because if we compare it with flood studies, they actually already for a long time include the human effects on the properties of flood. And actually also they know that human factors can both intensify and reduce flooding, which I argued is also the case for drought. So coming back to Ben's paper, he said that the universal description of drought requires a reference to water supply, demand, and management. And I think that it is crucial not only for quantifying drought, but also for really understanding. So with that, I thank you for your attention, and I open the floor for discussion, because I guess there's a lot of things to discuss here.